Hello, my name is James Murphy, and welcome to another instructional video for the instrumentation in the Yale School of Medicine CCMI X-ray core facility. Today we'll be looking at the Formulatrix NT-8 drop setter. This robot is a very useful tool for crystallization experiments as well as advanced liquid handling. For crystallization experiments, it can easily set up hanging drop experiments, sitting drop experiments, as well as LCP experiments for membrane proteins. My contact information, as well as the contact information for the Formulatrix company, are shown below. Please do not hesitate to call me for any problems or for training hands-on with the instrument. Now I'd like to show you the hardware setup for when you use the Formulatrix robot. This is the robot itself here. First thing you want to do is turn it on. There's a blue LED light. If that's on, the robot's already on. If not, there's a on switch back here by the power cord. Please flip that on. You want to take the distilled water reservoir and fill it up to the maximum line. Either bring milli-Q water from your lab, or you can go to Dr. Singh's lab down the hallway in SHM B17 and ask them for some distilled water. The waste container is down below. That should be empty when you start. Please let me know if it's not. And the control computer is located here. Additionally, you'll need to bring all your own plasticware and pipette tips, and of course your sample and your screens. Okay, so now I'd like to show you the basic software setup for the NT-8. The computer should have the login screen as such. Log in with your net ID or a local ID if you're a user outside of Yale. So your desktop should come up and look sort of like this. What you should see is a shortcut for the NT-8 program, a folder called sample, and a protocol file that's yours that you may or may not need to make. One thing you should do, start the web browser. You'll go to schedulebook.com. That should pull up today's date. Go to Tools. Go to today's date. Go to Tools. Choose New Event. Pick the NT-8, today's date, the time you'll start, and the time you expect to be finished. And you can update that later if you don't use your entire time. Also in the event note, you want to put your COA number for charging. And you'll see you're signed up. An additional resource you should have bookmarked is the manual from the NT-8 for advanced setup. And to answer some simple questions. And that's at help.formulatrix.com/NT-8. So back to the desktop, there is a shortcut to the NT-8 software. Double click that. It takes a second to start up, so be patient. Okay, when it connects to the device, it may give you several options. If it wants you to sterilize the system, do not do that. I'll do that. If it asks you to purge the system, please do that. Also on the desktop, is a shortcut to a folder full of sample programs that are all set as read-only. You can use those to start and adjust them. And then what you would do is, once you have a protocol that you like, save it to your folder on your desktop, and that will prevent it from being corrupted by any other users. Okay, so that's the basic software setup. Okay, so in this section, I'm going to show you how to use the NT-8 to duplicate a plate to make a crystal screening plate from a deep well block. What you're going to need for that is your deep well block, which would either be a commercially prepared screen or one you've designed and made yourself. And then your trays that you would use for either a hanging drop or a sitting drop setup. Some aluminum foil covers, and the brayer. And the part numbers for the commonly used blocks, plates, and sealing tape will be on a following slide. So for this demonstration, I'm going to run the NT-8 with the cover open by bypassing the switch. Please don't do that when you're using it. So if we look at the software, at this point the software is open, and what we see here is a representation of the deck, and this is an empty starting template for you to make your own task lists. So what I'm going to do is open a task list that will do a plate copy. So I'll go to my desktop, my protocols, pull up a plate copy which I have named 100 microliters deep well to 96. Okay. So now it's populated the deck where we'll put our hanging drop plate in this position. In this case, it's the name of it in the software is a Griner Assay Clear. That's a pretty common shaped plate, so that'll work for BD Falcon, CoStar, most of those. And the deep well block will go in this position, and in this position is going to be the high volume tip caddy. Okay. For the high volume tip caddy, you're going to need packs of 96 well plates. It's required that you use this particular type of 96 well tips, and the part number is here, and it will be on the bottom of the screen. You can get those from Formulatrix or from Fisher. Okay, so if we look at the task list, the first thing it's going to do is set up a repeat because it's going to work in the Y direction. So it'll pick up tips from the high volume tip caddy, which is indicated here. So for the plate copy task list, if we look at each line, it starts with a repeat where it repeats in the Y direction. Then it's going to have a pick tip step where it picks up the high volume tips from the high volume tip caddy, which is represented here. Then it's going to aspirate using the high volume tips from the deep well block represented here and go through columns 1 through 12 in a repeat. And in this particular case, I've set it up to 100 microliters. If you want to change that, simply double click on it and we get this dialog box where we can put the volume in here and change it. And also we can change the liquid class, and that's based on viscosity. So you have normal, medium, high, and very high. Typically for a sparse matrix screen, you want to go with high or very high so that you get the proper amount in each well. The next step is where it dispenses the high volume tips into the assay plate here. Again, it's columns 1 through 12 and 100 microliters. For the viscosity setting, it should be the same for the aspirate and the dispense for the plate copy. And finally, it's going to dispose of the tip back in the high volume tip caddy and then repeat. So let's set up the deck. So the lid should normally be closed. There's 3 buttons here that allow you to move the head around to different park locations. Right now it's in position 1. So if I move it to position 2, the head will move over. That'll give you access to this part of the plate. Let's go back to position 1. In this example, I'm going to use the hanging drop plate. It'll go in this position, and it should lock in tightly and be held. Next, I'm going to put the deep well block in there. I would suggest you bring them to a centrifuge and spin them down before you use them, and also bring them up to room temperature so the liquid gets transferred properly. Okay. And you want to ensure that the A1 well is where it should be, in the top left corner. And again, that block should fit in there snugly. The next thing we have to do is put in the high volume tip caddy. So I'm going to move it to park position 3. And that gives us access to the high volume tip caddy. I want to take one of the tip boxes, open it up, take the lid off. We don't need that anymore. And then this fits in with the hinges towards the rear of the robot and slides in this way and will snap in position when it's all the way in. At this point, since you've added a new tip caddy, we want to reset the tip caddy and let it know that it's a new one. So if we right-click here, new tip caddy, and you can see that's changed to 96 tips here. Okay. We're almost ready to go. The last thing to check is to make sure that the representation of the deck in the software is the same as the representation here. If there is a plate where it doesn't expect it, you may experience a crash. So once you're confident with the positions on the deck and with your task list here, push this play button, which will run the task list. Typically you want to run it in the humidifier in automatic mode. I'll get to that in a future video. Once you're satisfied with the placement on the deck and your task list, we'll go up here and press the play button, which will run the task list. So the head contains basically 2 multi-channel pipetters, one for the high volume tips and one for the low volume tips. So it's going to go over, pick up a set of high volume tips, go into the deep well block, aspirate the 100 microliters or whatever you choose, go to the assay plate, dispense it, go back to the tip caddy, eject the tips, get new ones, and continue until it's done the entire block. It is possible to set up where it will do more than one, up to 3 copies at one time if you use the other 2 positions on the deck. You just have to program this several times. Okay, so when it's finished the task list, it'll put the head back to this position. It'll tell you it's done, and it'll play a pleasant sound to let you know it's done if you're not right next to it. Okay, so what you'll do is you'll take your screen plate out and your deep well block out. And put an aluminum foil cover on and seal it with the brayer. Use the computer to move it to park location 3. Take out the used tip caddy and dispose of it. If you make a lot of these, please bring them back to your lab and dispose of them there. And then the deck is ready for either the next experiment where you could do another plate copy or to move on to setting up a different experiment. As far as the software goes, when you're done, all you have to do is close the software and log out of Windows. And that's how you do a plate copy. Okay, in this next segment, I'm going to show you how to use the Formulatrix NT-8 robot to set up a typical hanging drop crystallization experiment. To do this, the material you'll need to bring your 96 well tray with your screen in it that you either dispensed by hand in your lab or you use the NT-8 to do a plate copy from a deep well block. You'll need to bring your protein. You'll need 50% ethanol and some Kim wipes, which should be here. You'll need your pipetter and some tips. You'll need the brayer once again. You'll need your plate seal. These here are TTP Labtex View Drop 3 UV plate seals. Those are compatible with the UV imaging on the Formulatrix RI1000. And the part number is there. There are also a variety of other plate seals at work, but keep in mind that the thickness may be slightly different. So I'll help you do a test run before we do those. Also, specifically for the hanging drop, you'll need this silver block, which the seal goes onto, which should be here in the drawer. And you'll need this jig that attaches the silver block to your plate seal. Also, you'll need to select either the low volume or the high volume protein block. The low volume holds up to 5 microliters and the high volume holds up to 20. Each of those comes with the corresponding either low volume or large protein trays that should be in the drawer here. If you plan on using a tremendous amount of these, please purchase some for yourself. You're also going to need the low volume tips that actually transfer your screen and protein. Those are located here on the deck. If this runs low, please let me know. I will exchange it with a new caddy, which are here. They're in the drawer. They're extremely difficult to change, so unless you can't find me or someone else that's done it before, that's the only time you really should attempt this. Each experiment typically uses 8 tips. So just make sure you have enough. For the computer, for the software, for the hanging drop, so you'll open your task list. And I have one here called hanging drop 400 nanoliter plus 200 nanoliter. And since you'll have your own directory where you can keep all your protocols, you can name them appropriately. So we'll open that. And again, we see here that there's a representation of the actual deck that shows what you'll need to have in what position. So we have our grinder assay clear plate. That's your screen that you brought with you. And then the UV3 plate seal is here. So let's look at what the task list for this is. First, it's going to pick up a tip from the low volume tip caddy. Then it's going to start up a repeat where it's going to do the 12 columns. So at the beginning of the repeat, it's going to wash the tips for 4 seconds in the wash station, which is over here. So this robot reuses the tips and washes them between each transfer, as opposed to the Mosquito, which uses new tips on each transfer. Formulatrix guarantees that there's no cross-contamination between samples. Thus, we use much less tips, and it's cheaper to operate. So the next step in the repeat is to aspirate from the protein source, which is over here. So if I double-click on that, you can see from the high-volume tip block, and you'll know you have to use the high-volume tip block because it has this large H here. We'll be aspirating from column 1, which is on this side. And it's going to pull up 400 nanoliters of your protein. And if you want to, you can adjust accordingly here, and you can adjust the viscosity here. Typically for protein, I leave that on very high. The next step will be to aspirate your screen, where the tips will come over to the screen and pull up an additional 200 microliters of the screen. So at that point, you'll have both the protein and the precipitate in the tip at the same time. That allows it to mix as it gets dispensed and also ensures the placement is in the same position. If you want to change that, double-click on it. You can change the volume here and the viscosity here. Now you'll notice that for the repeat, in this case it's 1 through 12, and for the dispense it's 12 through 1. For 1 through 12, the arrow is going this way. That's the direction it's going to go. And then when we get to the next step, which is the dispense, here the arrow is going the other way. The reason for that is it will dispense column 1 from the plate onto column 12 for the seal, so that way when you flip it over and seal it, it's a mirror image and it corresponds to what your precipitant is. And again, you want to make sure the viscosity is set to what you like, and the volume for dispensing will simply be the total of the 2 aspirations. It will do that 12 times and then end repeat. It is possible to do parts of the plate. If you have a small amount of protein or multiple proteins, you can set up situations where you only do a partial plate. Okay, so let's set up the deck. So the first, I would set up your screen here, which is in this position. Again, you want to make sure to allow the screen to come to room temperature, especially if you plan on using the imager, which is already set to 20 degrees. and spin down the plate to make sure the liquid is in the bottom to get a proper transfer. Okay. Ensure position A1 is in the top left. It should snap into place. Next, you want to set up the plate seal. So get the silver block, and there are 4 circles with crosshairs in each of the far corners. It might be a little difficult to see here. Get your plate seal ready. And the idea behind the 4 circles is to line up the 4 corner wells. So take the 50% ethanol, put some on the block, and get a Kim wipe and spread it evenly. We're not trying to clean it, we're just trying to put down enough ethanol so that when you put the seal on there, the surface tension holds it in place. So I typically bend the seal, place it down like that to minimize air bubbles, and then push seal into position to line up with the crosshairs in the circles on the silver metal. It's critical to get that as close as you possibly can. That's going to dictate the position of the drop within the well and how the well sits, how the well sits on top of the plate itself, as well as the imaging later should you use the RI-1000. Take the silver block, place it in this position, which corresponds to this position. And the last thing is to set up the protein. You want to do that last so it doesn't evaporate as you're setting up the rest of it. So I'm going to move to park location 2. You'll take the high volume block, take the magnetic cover off. It fits right in there. Take one of the disposable trays. And it fits in the block like so, and then the magnetic piece holds on, and you should be ready to go. So it has 3 columns, so it's easy to set up fairly complicated experiments where you have 3 different proteins, or 1 protein at 3 different concentrations, or a protein with several ligands, or whatever you can design. In this case, we're using column 1 here. Okay, what's nice about this is if you tell it that you're going to use 400 nanoliters of protein per drop, it will calculate how much you should put in each of the wells so it can do the experiment. So typically 4 times 12 would be 4.8 microliters. It's asking for 5.3 microliters in each of these wells, as the machine's not 100% efficient. And if we were to change that volume to 600, the demand would change appropriately. Take your pipetter and your protein, place it into the wells. You want to try not to make any bubbles. If you start making a bubble, don't get too fussy about it, because you're probably just going to make it worse. Okay. And you always want to be sure that there's nothing unexpected on the deck, like a cap or a tube or a pipette or anything. That would cause the machine to crash. Okay, so once the position of the equipment on the deck matches what the software has, and you're satisfied with your task list, you can start the program. Again, push run here. I'm running it with the cover open, bypassing the switch so we can see. Please don't do that. So it just picked up some low volume tips and it's washing them in the wash station. Now it's gone over to get 400 nanoliters of protein out of this position. Now it comes over, gets the screen out of column 1, dispenses 600 in column 12. Comes back and washes the tips, and we'll repeat this 12 times. As it's going, you want to keep an eye on drop placement and how well it's doing. If it's doing very poorly, let me know. One thing I should mention about these low volume tips here is that the representation that's on the screen, check to make sure that's the same as what's actually on the robot, as it can't sense whether there's tips there or not, and if there's an error between that, it'll be going for tips that don't exist. Okay, so it has completed the protocol for the hanging drop. Again, we have a message that it completed, and it's playing a little sound. Click OK on that. So now to get the hanging drop ready for the imager or incubator storage, you're going to want to get this jig, place it here, carefully take your screen out, place it in here. The A1 position should be by the pole, and it should clip in place pretty well. Next, you'll want to lift up the silver block that has your drops dispensed. And then what you're going to do is flip the block over. And you're going to want to do it sort of casually, not too fast, not too slow. Just flip it over. Place it against the 3 vertical poles and have it level. And then lower it down onto the plate. At that point, give it a good amount of pressure. And slide the silver block out of the way. Put it to the side. Take the experimental plate out of the jig. Use a Kim wipe to wipe away the extra 50% ethanol. Get the brayer. Okay. Ensure it's sealed. And then the final step, there's a layer of plastic that serves as a protective film for the optically clear UV transparent layer that the drop is set on. You want to remove that. It's much thinner than the other layers, and it can be kind of difficult to get sometimes. Okay, so that peels right off, like so. If you feel like you're taking the glue off, you're actually removing the lower layer, so just be gentle with that. Once that's off, good. And this plate is ready to go into the imager or into your incubator. You don't want to use the brayer again at this point. That will disturb the drops and scratch the surface. Okay, so to clean up after a hanging drop experiment, We'll put the jig and the block back into this drawer here. You'll take your tray away. You'll want to remove and dispose of your protein strip. Close the lid. And take your pipetters and ice and everything else. The brayer goes back in here. And the spare protein blocks also go in here. And that's it for setting up a hanging drop experiment. Okay, so in this segment, I'll show you how to combine both the plate copy and the hanging drop experiment into a simple single task list where it will do both sequentially. So if we go into the software, and we open up a task list that I've made, where it's hanging drop 400 plus 200 nanoliters with plate copy, and open that. We'll see here the representation of the deck and how it should be set up here, and our task list. So this is the combination of the previous two task lists, where we have a repeat that makes the assay block or assay plate from the deep well block, and then the second repeat creates the hanging drop with the protein. So I've already set up the deck, deep well block. We have to tell it it's a new tip caddy. We have our low volume tips. We have our plate seal and an empty tray here, and I've already loaded the protein. So at this point, we close the lid, and I'm going to turn on the automatic humidifier. So the design of this is such that there's 3 humidifiers that fill the chamber with humidified distilled air, which comes from the same water source as the tip washing station. The open environment really allows an even level of humidity in there. You can either turn the humidity off or on, or use it manually when you like here. And you can set it to a certain amount. So I believe it's set to 80%, and that's where it will limit out at. Once we're comfortable with the amount of humidity, we can start the program. So now it will go through, copy the plate, and then go right into setting up the hanging drop experiment. So once it's done, the end of the experiment and the cleanup in the software is the same as if you did either experiment by themselves. Okay, so at this point, the robot has finished doing a plate copy from your deep well block into a hanging drop experimental plate. So let's say you wanted to make an additional plate copy for a sitting well drop. That's fairly easy to do. First thing we'll do is set up the deck. So if we use the same, if you want to use the same deep well block, you can also use the same tips. If it's a different block, new tips. Simply take out your hanging drop screen and then get an empty sitting drop. This is a 3553 Corning plate. Put that into position. And then we're going to go into the software and make the deck equal to this. So this is fairly easy to change a plate. You right click here and detach microplate. Then we go down the bottom and find the plate we want. In this case, it's a 3553 Corning plate. Drag it up, and there it is. Since we're running it again, right now we're at 0 tips. You're going to right click and new tip caddy. Now we have 96. Like I say, we're going to reuse these since it's the same screen. Then we'll look at the task list and adjust that. So first, again, it's going to pick the tips and do a repeat 12 times. So if we go into aspirate, for sitting drops, most people put in 50 microliters of well solution. And then you'll set the viscosity based on what you have. Since this is a screen, we'll do high viscosity or for all 12 wells. And then the dispense should be the same volume, 50, and the same viscosity. Okay, now you're ready to run it, and it will make a copy in the sitting drop from the deep well block. Okay, in this segment, what we're going to do is set up a sitting drop experiment in a Corning 355 plate with 3 different proteins with a single screen, and we'll do it in line with a deep well block copied to the sitting drop experimental plate and then the protein. So the first thing we'll do is set up the deck area. So you want to have your set of high volume tips. You want to take your empty 3553 plate, place that in this position, and take your deep well block and place it in this position. Also, you're going to need a protein strip for the 3 proteins. Lift up the magnetic cover. That should fit in there nicely. Okay, so the deck is ready to go except for the addition of your protein. I should always do that last, so in case there's a problem with the computer, it won't evaporate. Okay, so if we look at the software, what I'm going to do is open up a program or a task list that's called Sitting Drop 200 plus 200 nanoliters, 3 proteins with the plate copy, 50 microliters. So open that. Okay, so let's look at the deck first. We have our 3553 plate in position. We have our deep well block in position. We have our disposable tips in position. Right now it says 0 tips remaining. So what you'll do is right click and hit new tip caddy. Now that should be ready to go. Let's look at the task list for this program. First, we're going to start with the repeat of the plate copy, which we've seen before. And then we get into a repeat to set up the drops. So first it's going to do is aspirate from the Corning 3553 plate, and it'll pick up 200 nanoliters from the reservoir part of the well. Then it's going to go over and aspirate from column 1, here in the high volume protein strip. Then it's going to dispense into drop 1 on the plate, and then end that repeat. The subsequent 2 repeats will be protein column 2 and drop 2, and protein column 3 and drop 3. And at that point, it will tell you how much protein is required per well. Just pipette your protein into the protein reservoir. Press the start button, and the program should start up. All right, in this segment, I'm going to show you how to use the Formulatrix NT-8 drop setter to set up LCP plates for trying to crystallize membrane proteins in lipidic cubic phase. So the material you'll need for that is, most importantly, you'll need a syringe of your protein reconstituted in lipid. You would have set that up in your wet lab at some point. And please see me to get the proper syringe that fits the robot. You're also going to need to get some LCP glass plates. I typically buy them from Hampton. If you need a large quantity, you can get the individual components in bulk. And that consists of a glass plate with a 96 well tape layer, and also a glass cover slip that fits over when the plate is finished. You'll also need your experimental screen. So let's look at the software setup. So in this, the deck is laid out as so. You'll have your screen set up here. We'll have the LCP sandwich plate set up here. And that's all we need except for the syringe. So in the task list, what it's going to do is pick up some low volume chips from here, aspirate, and in this case we're doing an 800 precipitant 50 nanoliter LCP mixture. So it'll aspirate 800 nanoliters from the screen. It will then use the syringe to dispense 50 nanoliters onto the LCP plate, and then it will go and dispense the screen right onto the LCP drop. And the reason for that is to minimize the time that the LCP is exposed to the air. When it's done, it will dispose the tip, and that'll be the end of the experiment. So to set the deck on the Formulatrix up, fairly simple. First, put your condition screen in this position, and then you'll want to get the LCP plate ready. So we're going to use the same silver block as we used in the hanging drops. And if you remember, it has crosshairs and circles at each of the 4 corner positions to help you align it with the positions on the plate itself. So we'll take a little 50% ethanol and spread that out to prevent the glass plate from sliding around on the block. You'll notice there's a wider end at this end of the glass plate. That should be towards the 12 end, and that's for the position of the barcode for the imager. So line that up to the crosshairs. Place that on this position in the robot, and you're ready to go. So all you'll need to do now is set up your LCP syringe onto the head, which we'll get to in the next segment. So now we're going to load the LCP syringe onto the robot, onto the syringe holder. This switch here controls the up and down movement of the clamp that holds onto the head of the syringe barrel. Basically, if the syringe fits like this, get it lined up like that. And we're looking at the top of that part of the syringe to line it up with that gap. It fits right in. Snaps into position. Then we tighten this screw down. There. At that point, if it's in properly, a very small amount of LCP should come out of the end of the syringe, and you'll just want to wick that away. So now we need to calibrate that syringe, as all the syringes are slightly different. Okay, so now we need to calibrate the syringe. And the reason we need to do this is every syringe is slightly different. So to ensure proper drop setting at the same position on the plate, we have to measure the syringe. So the software has told me that it knows there's a new syringe in there and asks to calibrate it. So before I press yes, if we look over here on the deck, this is the calibration module where the syringe will come down into. and there's some sensors in there that'll identify the exact XYZ position of the tip of the syringe. So if we go calibrate now, and you want to tell it the correct syringe size, 100 microliters. And it will calibrate the syringe, and this will identify each syringe. And you have to calibrate each syringe every time you do it because of the fact that the end of it might have gotten bent a little bit, or the it's not exactly in this right position. If it fails during the calibration, that means it's bent so much it's not usable. So if we look on the software here, it'll give us our new reference position for the tip of that syringe in X, Y, and Z, and stored in the software. So we're ready to go. So we have our screen, our LCP plate, and our syringe loaded. I'll hit start. So the first thing that we'll do is pick up the condition screen. Then the syringe will come over, do 3 test ones right at the end, just to get the LCP flowing. Then do column A with the LCP. Bring the precipitant over, put it on top of the LCP drop, and repeat. At the end of this, you'll remove the LCP base, take off the protective layer onto the adhesive surface, and place one of the large cover slips on top of that, and use the brayer and bring it to the imager for imaging and analysis. Okay, now I'd like to explain how to clean up the system after you're done using it. Use the software to move the head over to this position so you can access the deck. You'll take all the plates and material that you brought with you and dispose of it. Or you want to make sure you take your protein sample strip out of here and throw it away. Also, the used low volume tips are in this container with the little hooks on there. That'll fit in there. Empty that into the waste bucket. And once it's empty, it should snap in where it was. I'm going to take the waste bucket, unscrew it, dump this in the sink that's over by the Griffin, and run a bunch of water with it to flush out the sink, and then clean up any spills you may have made around the sink. And finally, refill the milliQ water up to the maximum level for the next user, and make sure the cap is on tight. As for the software, you'll save your current method if you like. Close out of the NT-8 software. And log out of Windows. It's okay. You should leave the robot on. The blue light will remain on. After that, just make sure all the material you've used is cleaned up and brought back to your lab. And good luck with crystal growth there.